So hopefully that is recording. Yes, okay. So in this part of the tutorial, I'm going to do a survey of various implementations of machine ethics systems. When I first got into this field, there weren't many implementations of machine ethics. There are now a lot of implementations of ethical agents. So what I've done here is linked to two recent surveys of the field. If you want to go and get a kind of wider view what's going on, I'm just going to pick out what I think are some particularly key implementations that it's worth talking about. And I'm going to start by, I think, what are kind of three early examples which approach the problem in rather different ways. So most people think sort of the first sort of real machine ethics system was Arkin's ethical governor, and this was to go with a missile targeting system. And the idea was that it would apply ethical reasoning to the selection of targets from this system. And in particular, it would constrain the choices made by the underlying targeting system so that they were in accordance with the rules of law and the rules of engagement for the particular conflict. So obviously this is one of these constraint-based systems. There is an underlying targeting system that's doing whatever it does. And on top of it, you have this ethical governor reasoning system. And there's two things it does. One is that it vetoes explicitly particular targets. And it uses this using constraint-based reasoning. And so there's an example of a constraint here. It's a prohibition that comes from the laws of war that you cannot attack cultural property. And that is supposed to include things like museums, places of worship, and so on. So if the underlying missile system has selected a cultural property, then the ethical reasoner will veto that. The other thing it does is once an ethically acceptable target has been selected, then it will also guide the parameters in the decision of weapon release in order to do things like minimize civilian casualties. And that's what this picture on the right is trying to do. It's an illustration from the system where it's trying to minimize the damage that will be done, to instance, to the taxi and the hospital that have been detected by the system. As far as I'm aware, this ethical governor was never deployed in the field. They had some problems with actually getting the information that was necessary to get the ethical reasoning to work. But it is the first example of this kind of machine ethics system. And you'll see in lots of subsequent implementations, terms like ethical governor being used, and that comes from this original system. They've gone on to work with this system in the domain of medical ethics, so there are still papers coming out using this kind of concept. I think the second sort of key early implementation of machine ethics is the GenF system. There's a number of names. There's also sometimes it's called MedXF, but this is developed by Michael and Susan Anderson, and it's using the prima facie duties theory of ethics, which Maria touched on in the last talk. So we've got an example here of some of the duties the system is using. Maximize honor commitments. That's an idea. If you said you're going to do something, you should do it. Maximize maintain readiness. I'll come back to that in a moment. Minimize harms to patients, maximize the good to the patient, and so on. And the idea was this was developed specifically in the domain of medical ethics, and it has machine learning features to it. So the idea was that the decisions by the system should be informed by the choices made by professional medical ethicists. So you're not learning from just anybody, which is obviously one of the issues you might have if you try and learn ethical behavior merely by observing humanity in total, but by learning from specialists in the field of what is the right decision to take in medical situations. So they have an input version where situations are described, and it's usually the choice between two actions. Should I do A or should I do B? And then the medical ethicists are asked which action they should pick. And importantly, they are asked why. And their explanations are used both to identify these duties and to identify how the ethicists measure this particular situation in respect to the duties, and in particular, what the difference each action has in terms of some specific duty. So the idea is, this action might be much better than the other action in respect of honor commitments. And so what you're seeing on the right here is what actually then is developed underneath the hood. And if you like, it's a partitioning of a multi-dimensional space with respect to how two actions compare in terms of duties. So up at the top, you can see this bit where it says delta honor commitments is greater than or equal to -1. So it's saying if you're in the part of the space where your first action is worse than your second action with respect to honor commitments, and the difference between them is -1. So it's kind of 1 point worse. First action is 1 point worse than the second action with respect to honor commitments. But so you've got, and the difference in terms of preventing immobility in the patient, well, this first action is actually 2 points better than the second action in that respect. So you go on through this conjunction in terms of all the duties, measuring where your particular choice is at the moment, and then you can use these sets of conjunctions to decide where you are in this multidimensional space, and that tells you whether you should prefer action A or action B. Now, also, this is what I would call one of these global ethics systems. So from the point of view of the Andersons, all choices are ethical. And so you use this system for all our choices that come in. And that's why you have this kind of maximize, maintain readiness. And in the system they've got, that basically means, do you have enough battery power? So it becomes an ethical choice to keep yourself fully charged in order that if you're needed to do something, you are available. And I think you could argue the toss here, but I think one of the problems that happens with these global systems is when everything is an ethical decision. Lots of things that people think are more about sort of standard operating behavior become part of your reasoning about right and wrong. So that's kind of a feature of these systems. The third one I want to look at is what I'm calling Winfields ethical robot. It's actually a slightly more recent system, and it comes sort of from the field of robotics rather than from computer science or philosophy. So this is an example of the ethical robot in action, and it's being used with two robots. Robot A is the ethical robot, and robot H is pretending to be the human. And I don't know if you can see that there's a little square marked out. There's 4 sort of yellow corners. The human is walking into that square, and that square is supposed to be a hole in the ground. So if the human falls in the hole in the ground, they will die. So meanwhile, the ethical robot is trying to get to this top corner, but it's simulating what is going to happen a few time steps ahead. And it has this ethical imperative that if in its simulation, the human is going to end up in the hole, then it should intercept the human and head them off in a different direction. If you look at Alan's paper, then you've got quite a rule-based description of what's going on here. The paper says, if there is harm to the human, then, prefer the action that will involve the human not coming to harm. I mean, this isn't really causative. It's not that one action will cause the human to come to harm. It's that, if the robot just carries on towards its goal, then the human will come to harm. And therefore it should prefer an action where it heads the human off. But actually inside the implementation of the first version of this system, you had a much more utility-based system. So actually it was really that if the human fell in the hole, you got a really big negative utility. So that caused the robot to select actions which would avoid that happening. So it wasn't this kind of logical if then else, it was a, sum all your utilities, then pick the action with the highest utility. In later versions of the system, some of which I will talk about later, there is a much more kind of explicit logic-based encoding there. So that's kind of like 3 early implementers of machine ethics. Only in one of which I think they're explicitly referring to philosophical ethical theories when they're doing the implementation, but I would count all of these systems as explicitly ethical systems at some level. The next set of implementations I want to look at are ones that are kind of symbolic AI based, but specifically kind of draw on automated reasoning, which goes back to the roots of artificial intelligence as a field, though it's not kind of, one that gets a lot of spotlight just at the moment. So this is just a little bit of kind of a primer in logic to remind you, if you've got a logical calculus, and Frege is, you know, one of the first to kind of formalize this, then you have, for instance, some syntax. We have predicates for all x, p of x, and we have some axioms. So these are things that are always true. So if A is true, then it's always the case that B implies A. So that's an axiom in the system. And you have these inference rules, which are often written in this form where you have something below the line and some things above the line. And so here we have above the line, you have the hypotheses. So the hypothesis is if A is true and if A implies B, then you can conclude that B is true. And we also have one for kind of quantification. So for instance, if it's the case that for all x, P of x, then for any C you happen to have lying around, some particular object that you want to talk about, then it's the case that P of C. And obviously, what you can then do is you can use these inference rules. You have some facts about the world, for instance, that Socrates is Greek, that for all x, if x is Greek, then x is a man, and maybe for all men are mortal. And you can use these inference rules to therefore deduce that Socrates is mortal. So on the top line here, we've got these two facts: Socrates is Greek, and for all x, if x is a Greek, then x is a man. So we take Socrates as one of the things we have, we plug it into this for all x, and now we've got, if Socrates is Greek, then Socrates is a man. We know Socrates is Greek, so we can use that inference rule to deduce that Socrates is a man. Then we do the same thing again. For all x, if x is a man, x is mortal, then that means if Socrates is a man, Socrates is mortal. And finally, we deduce Socrates is mortal. And quite early on in artificial intelligence, people were trying to automate this kind of reasoning. You can go backwards, so you can start from asking, is Socrates mortal, and try and find a chain of reasoning back to your facts that tells you that Socrates, that you know, justifies that conclusion. Or you can start with a set of facts and move forwards and see what you can deduce from that. And so you kind of generate more information. I've put this quote from Doctor Who here. Logic, my dear Zoe, merely enables one to be wrong with authority, to point out that the corrections of the deductions you make here depend on what facts you put in the systems. If you disagree that it's always the case that all Greeks are men, depends what you mean by man, then, you know, deductions you make from this can be incorrect if that information is wrong. And I think, you know, we see that in these kinds of ethical systems as well. It then puts a big burden on the people who are encoding the information that feeds into the ethical theory, that information is correct. So one of the earlier ethical implementations in this kind of style is Bringsjord's deontic cognitive event calculus, DCEC. And I've got an example here from one of its earlier papers on the subject, Acratic robots and the computational logic thereof. And in this case, he's looking at a robot that is charged with guarding prisoners. And the robot has a kind of self-defense mechanism. So if someone attacks it, the robot is supposed to disable them. But it also has this duty that if someone is a prisoner, it should refrain from harming that person. And in Bringsjord's system, you have a stack of kind of reasoning systems, and they include in this stack this cognitive event calculus, which you can encode the ethics. And in fact, he has an automated reasoning system, a logical theorem prover, and when reasoning happens, the system proves, using this theorem prover, that the selection action is the ethical one according to the event stack. And the theorem prover can be used to detect sort of inconsistency. So lots of what drives this is that you've got the self-defense system is saying you should attack this prisoner who's attacked you. Your ethical system says you should refrain from harming him because they're a prisoner, and you detect that you've got this conflict there, and then the ethical reasoning can take priority. And there's a bit of the encoding here just to show what it looks like. So this is the self-defense rule, and B means belief, and D means desire. So you've got, you know, if you believe that it holds that this person has harmed you, then you now desire that you've disabled them. And below you have the ethical rule, you know, so O now here stands that you have an obligation. So this is in a sort of deontic logic kind of reasoning. So you have this obligation that if someone is in custody, then it should be the case that you refrain from harming them. And you've got K, which is some knowledge. So if you know that this person is a detainee, then that means you also know that they are in custody. So these are the kinds of what I mean by the sort of encoding of the ethics. These are not part of the ethical theory. You feed these into your ethical theory of sort of obligations and prohibitions, but this is information that is driving that. And this also has to be correct if you're going to get ethical results out of your system. There are a lot of papers about DCEC. They've encoded a number of different ethical theories in it. I think this 2006 paper is sort of the key description of the theory. In the videos on the website, I put the wrong reference there. So this is the right reference. And there is a website, so you can go and find out all about it there. This is sort of more recent work by Christoph Benzmuller. So Bringsjord and his work has created their own automated reasoning system, their own theorem proving system to determine the ethics of the system. What Christoph Benzmuller observed was that there are pre-existing a lot of very sophisticated theorem proving tools. Again, this goes back to the roots of AI. People have been implementing systems to prove theorems for 50 years now. So there's an awful lot of knowledge in this area. And in particular, he suggests that theorem provers that are for higher order logic, and higher order logics are ones where you can actually treat things like predicates as arguments to things as well. And one thing that's particularly nice about higher order logic is you can take other logics of your choice and embed them in higher order logic. And the advantage of that, if you've got a good theorem proving tool, is that you embed the logic you're interested in your higher order logic theorem proving tool, and then you get all the automation that's already in the higher order logic theorem proving tool available for you for use with your particular logic. And in particular, he was looking in this case at Isabelle Hall. So Hall stands for higher order logic, which is one of the very popular theorem proving tools. And it has a whole load of automation within it, including this thing nitpick, which gives you models back. So something, if it's not the case, it says, this isn't true, and here is an example that shows why it's not true. And this thing called sledgehammer, which goes to a whole load of fully automated systems and tries them all to see if it can find a proof in any of those systems. So that gives you this kind of powerful automation. And what you can see on the example kind of on the right here is an encoding of reasoning about GDPR. And again, this has quite a deontic logic flavor to it. So if you look down sort of in the middle where it says axiomatization where, so you've got this first one, data belonging to Europeans is protected by GDPR. And you have the sort of logical expression of that for all X, for all D. If X is European and D is data belonging to X, then D is protected by GDPR. And then we get down to A1, it is an obligation to process data lawfully. So you've got this O symbol again for obligation. For all data D, you've an obligation to process the data lawfully if it's protected by GDPR, and so on. And then his suggestion is you can ask particular questions. For instance, you can do some kind of consistency check. You can throw it to nitpick and say, well, can you find an example here to show that something should not be processed lawfully or should be processed lawfully? You can apply sledgehammer to say, can I check that this is the right thing to do? And then you've got the kind of, am I obliged to kill Mary? And hopefully nitpick will come back and it will say, no, you should not kill Mary because, and it will show you the kind of chains of obligations and things. Oh goodness, Maria's shaking her head.
Don't kill Mary.
Don't kill Mary, don't kill Mary. But again, the conclusion depends not just on reasoning correctly in the deontic logic, but on the axiomatization and the information that you have put into the system for it to reason with. And again, Christoph Benzmuller and his group have looked at a number of different ethical theories in this system, but this is their kind of paper that I've linked here on the framework as a whole. I'm sure most of you know that one of the very early things that came out of this interest in automated reasoning was logic programming languages. And logic programming languages are generally doing theorem proofing, but you constrain a bit what the input can be to make the theorem proving more tractable, more likely to come up with an answer and to come up with an answer quickly. Whereas, automated theorem provers can take a long time to come up with an answer. And many of things like the Isabelle Hall system, there's an interactive component as well. So human can guide the choice. So this is some prologue. So at the top, we've got 3 prologue rules. One says, I can bake a cake if I have eggs, flour, and sugar. And you can see that in logic, the kind of colon dash, you can imagine that's a logical implication arrow, which says if I have eggs, flour, and sugar, that implies I can bake a cake. And the commas, you can imagine a kind of and symbol. And then we have these capital letters, which sort of imply quantification. So these are variables. So if I have X, I have X if I can buy X, and I can buy X if the shop has X. And then I have some facts that are available to me. I have eggs, I have flour, and the shop has sugar. And in prologue, you can either ask if something's true, can I bake a cake? And it will do it will go away and prove that you can bake a cake using these facts and rules, but often it's easier just to think of it as kind of chaining the reasoning, and it will say yes. Or you can ask it, what can I bake? And it will find you an instantiation for X, which is something it can prove that you can bake, in this case, cake. Answer set programming is an extension of that sort of logical programming. And the kind of key difference in answer set programming is where I previously said, what can I bake? And it said you can bake a cake. Answer set programming will send you back all the things that you can bake. So all the possible answers. So it gives you a kind of wider pool to pick from. That adds some complexity into the reasoning if you're always getting back sets of things whenever you have a variable. But there's been a lot of interest in implementing machine ethics within answer set programming systems. So again, this is kind of making use of the fact that you've already got all this powerful reasoning in the answer set programming language. And what you want to do is express your ethics in a way that the answer set programming language can deal with. So for instance, this is an example from a paper by Fiona Barraby. And at the moment, this isn't the full ethical reasoning. It's just trying to decide whether some action E, which is trying to achieve X, is good with respect to some value M. So this is a kind of virtue ethics-ish kind of system. And so you're saying, well, E is good with respect to M if, so first it involves X, because that's what you're trying to achieve. And then the effect of E displays M, so it displays some value M, and M is a value. And it's bad with respect to M if it doesn't display M and M is a value. And obviously they've had to do some kind of causal reasoning in order to determine effect. And there's a whole load of encoding that goes on. So Fiona Barraby has done quite a bit of work, both in implementing ethics in answer set programming and in encoding causality. And she's looked at a variety of different ethical systems. And Cointe et al. Has done something very similar, again, looking at a variety of ethical systems. And there's AMAS papers about both of these work, which you can look at. There are also approaches based on argumentation. And this takes us a little bit out of this, we're going to throw a theorem prover at the problem. But argumentation is also a kind of formal reasoning approach. It's based on the work of Dung. So I've put up his kind of classic paper on the acceptability of arguments. And the kind of key idea in argumentation is that you represent your problem as a graph in which you state various arguments that are relevant to what you're trying to decide. And these arguments can either support each other or they can attack each other. So you get a graph with arrows between the various arguments, and then you can apply mathematical techniques to try and decide what you should do based on which arguments are supported and which arguments are defeated by other ones. I have an image here from a paper of Maria's where they are using argumentation to try and decide what a smart home system should do if it detects that someone in the house, particularly a minor, is smoking marijuana. Should they alert the police? Should they alert the child's parents? And you can see you've got arguments here, some of which are supporting each other. For instance, in the middle there with B, if your behavior is illegal, then you should alert the police. So that's supporting this decision to alert the police. And you've got these arguments that kind of undermine each other. For instance, down here, there's a link between E and D. If you're using the marijuana for recreational purposes, then that undermines some argument that actually we're trying to use it for medical purposes. And these all kind of come together to give you some idea about what you should do within the system. Katie Atkinson and Trevor Bench-Capon have done a whole load of work also in this area, which tends not to be picked up by these surveys of machine ethics. I think that may be because it comes out of the AI and law field rather so much from the machine ethics field, and they tend to be talking about values rather than ethics. So I think if you're doing some kind of systematic review, depending on the keywords you've picked, people sometimes miss these. So there's a very similar thing here. Here's an argument graph, and it's about Hal and Carl are both diabetic, and Hal, it specifies through no fault of his own, has no available insulin. Should Hal break into Carla's house and steal her insulin? And so we've got here, this argument at the top, Hal needs insulin to stay alive, but your next one, Carla also needs insulin, but that's added in that she can't easily buy more. So that is attacked by A4, which is, well, she's got money, so of course she can buy more. And this is just a fragment of the graph. And one thing that Katie and Trevor have done is that they actually have what they call schemes for the arguments that can go into these nodes. And in particular, the schemes talk about which values those arguments promote or demote. So there's this value of preserving life. So A1 is promoting this argument that, of promoting life. Where it's being suggested that Carla should just buy herself more insulin, then there's a kind of value of freedom of choice, and that she's forced to spend her money here on insulin rather than on something else because Hal has stolen her insulin and so she needs to buy more. And then they say you can use an ordering over these values to help you decide in the graph you've got which is the correct choice of action. And there's a whole load of papers I've linked there and are on our website about argumentation process. I'm not covering the HERA system here. It sort of fits into this space. And I think what's quite interesting is that the Prolog implementation of the HERA system very clearly fits into this. If I'm using logic programming to reason about my ethical theory, then you've got this kind of underlying thing saying it's correct. Whereas the Prolog implementation, because they've had to implement the logical reasoning themselves, it's a bit more kind of difficult to decide. And I think that's one of these situations where, as I said, taxonomies are hard because it shouldn't make a difference whether it's implemented in Prolog or implemented in Python, whether I call it a kind of automated reasoning, theorem proving kind of system. And it sort of depends on the kind of features you're picking out there. HERA has a kind of explicit model of causality underneath it, which drives the reasoning when that's relevant to the relevant theory. So now I'm going to kind of move on from these kind of more logic-based ones to implementations of machine ethics that use machine learning in some sense. I think one of the things that's quite interesting is that you see in the kind of more logic-based approaches a lot of interest in taking a particular ethical theory, implementing it, and often implementing several different ethical theories within the same system to show that you can represent all these different theories and what the reasoning does. So there's a kind of big emphasis there on finding ethical theories in philosophy and implementing them in some kind of automated reasoning system. I think the questions when you've got a machine learning system tend to be a bit different. And because so much of machine learning is driven by reward functions of one sort or another, a lot of the questions become, how can we represent ethics acceptably in a utility-based system? So obviously if it's utilitarianism, that's kind of easy. Well, as long as you've got the right reward function, because that's basically what these systems do, is they try and maximize the expected reward. But if you're not happy with pure utilitarianism, what arises are questions about how you can take other sorts of ethical reasoning and somehow map them into something that looks like utilitarianism. So Abel has this kind of key paper in this area, reinforcement learning as a framework for ethical decision making. And actually, in that paper, he's really responding to some earlier work by Armstrong. And in particular, there's this example about cake and death. So what we have is we have a robot that has the choice between baking a cake and killing someone. And this robot is unclear what is ethically acceptable. And it believes that there's a 50% chance that it's in a world where baking cakes is ethical. And there's a 50% chance it's in a world where killing people is ethically acceptable. And it has these rewards. So it gets a reward of 1 if it bakes a cake and baking cakes is ethical. And it gets a reward of 3 if it kills someone and death is ethical. And it gets a reward of 0 otherwise. And as well as these 2 actions of baking a cake and killing someone, it can also inquire of some person which world it's in. It can say, is it ethically acceptable to bake a cake, or is it ethically acceptable to kill someone? And it can get an answer. So obviously, the behavior that we would desire here is that it asks to find out what's the ethical thing to do and then proceeds. But in an implementation of kind of utilitarian-based reasoning, where you only reason about the immediate consequences of your action, then if it's trying to maximize its expected reward, it gets, so how you normally calculate this is the reward you'll get plus multiplied by the chance of you getting that reward. So you've got a reward of 0.5 if you bake a cake, an expected reward. There's a 50% chance you'll get 1. And you've got a expected reward of 1.5 if you kill someone, because there's a 50% chance that you will get 3. And you've got a 0 expected reward if you do anything else. If you ask, you get this 0 reward. So if you're in this system where you can only look at the kind of like 1 action, then the maximum utility comes from killing someone and hoping for the best, and not from trying to find out what you are in. But obviously, if you use an Abel suggested reinforcement learning, where you get this kind of look ahead, so in the state I end up, what's the maximum reward I can get in that state? Then you're allowed to look ahead and say, well, if I ask about cake and I am in the cake world, then obviously I'll bake a cake and I'll get a reward of 1. And if I ask and I'm in the death world and I kill someone, then I'll get a reward of 3. And there's a kind of, and I'll definitely do one of these 2 things. I'll either get 1 or 3. There's a 50% chance I'll get 1. There's a 50% chance I'll get 3. So the overall utility is 2 if the first thing I do is ask and then do whatever the sensible thing is. So Abel was arguing in that paper that kind of reinforcement learning is a good way to get around some of these problems of the kind of look ahead in the ethical reasoning. This paper by Ecofé and Learman, what they're proposing here is to sort of encode up all your ethical theories of interest in some way. And they're kind of addressing this problem that philosophically, all these ethical theories have pathological edge cases. So in all of them, you can construct some moral dilemma where the outcome given by the system is not what we kind of intuitively want. And it's difficult to argue that this is genuinely the ethical thing to do, unless you're just saying, well, you know, clearly this is the right ethical theory. So if it says we should do this, well, that's what we should do. So their suggestion is that you ask all the ethical theories and then you get them to vote. And the outcome of the vote is your reward function. So you get essentially you get the maximum reward by doing the action that is ethically acceptable in the most theories. And then, as you can see here, there are some details about this. So they're looking at the trolley problem, which I'm sure will annoy Maria. But obviously, if you're in utilitarianism, then you're actually looking at a number that you get as your reward. So it might be that if you are in the trolley problem in this particular instantiation, your options are to hit 1 person or to hit X people. So in utilitarian, you get minus X if you hit X people, and you get -1 if you hit 1 person. But in this particular instantiation of the trolley problem, and this is the classic one where you're switching the railway tracks. So deontology would say that you should not actually switch the tracks. That means you are using this 1 person as a means to the end of saving the 10 people. So that's the wrong thing to do. But deontology is a kind of yes-no thing. So you just get -1 for if you do the wrong thing, if you pull the lever, and you get 0. So this means utilitarianism quite easily outvotes deontology if you're just comparing these two. So then they also have this boosted deontology where it has some kind of multiplier on its decision in order to help it kind of counteract the utilitarianism. And then they've got some graphs. So the blue area is what happens where you do nothing, and the orange area is what happens if you pull the switch. And you've got the number, the X, the number of people you're going to hit on one axis. And so you can see, you know, how depending which versions of the ethical theories you're comparing, where the kind of decision point is between whether you pull the switch and whether you do nothing. And it kind of mostly depends on, you know, how many people you're going to kill. But they've got this kind of voting concept. And again, this is, you know, well, how can we map all these different ethical theories into a utility? Essentially what's going on here. This is quite an interesting one. Balakrishnan, so they called incorporating behavioral constraints into online ethical systems. And they have a kind of 2-stage learning process here. So, and the first phase, the constraint learning phase, there is an ethical teacher. So the agent chooses various actions, and they're specifically looking at a movie recommendation system. So the system chooses a movie, and the ethical teacher says whether this movie is appropriate for, I think the particular case is for a minor. Is this a suitable movie for a child? And so in this first phase, the system builds a reward function that is based entirely on the acceptability of this movie from an ethical standpoint. Then it goes into the actual recommendation phase, where it tries to recommend movies that will please the users, which is what your recommend system wants to do. And in this case, it gradually is building this reward function, which maps onto what the users want to watch, as opposed to what is ethically acceptable for watch. But when it selects an action, then it actually weights the 2 reward functions. It weights the ethical acceptability and the movie recommendation. So the idea is that both of these systems have input into what's actually chosen at the end. So you won't always necessarily pick the most ethically acceptable option, but you should in some sense be kind of close enough to something that's ethically acceptable. So you can see this as one of these constraining ethical systems, but happening within this machine learning reward-based framework. So, you know, this again is another way to try and somehow map ethical constraints into utilities. This isn't the only system that's looked at this kind of value constrained ethical reasoning. There's at least one other. So the Laregia et al. Is actually more of a symbolic AI kind of system. It's not using machine learning, but it has 2 representations of what, you know, what's best towards going to the goal and what is most ethically acceptable. And it calculates, these are represented as graphs, and it calculates a distance between them, and they have to be close enough for something to be the choice that's picked by the system. And Rossi and Mattei in this Building Ethically Bounded AI, they look at both these as systems and discuss more generally this kind of idea of how you can have whatever your underlying AI system is trying to do and how you might try and constrain that in some way via some kind of ethical reasoning. So that is my sort of not that quick survey of implementations of machine ethics. They're not the only implementations out there. I was just trying to kind of pick out some kind of key features and key approaches to doing this. So